Hello everyone, myself Piyush Antondil, working as Assistant Professor in Electrical Engineering Department of Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. And the name of subject is Industrial Instrumentation, which comes in 4th year, 7th semester. Right now we are discussing the chapter number 2, that is strain gauge and strain measurement. And this is the module number 3. Okay, first of all we are going to see the flow of content. In flow of content, this video lecture we are going to see the types of strain gauge. After that, grid type strain gauge. Inside of that, a rosette type strain gauge, torque and helical type strain gauge, characteristics of a resistance wire strain gauge, and then after bonded metal foil strain gauge, and last one, that is the semiconductor strain gauge. So let's get started with the types of wire strain gauge. Okay, in wire strain gauge we have different types of strain gauge, that are different four types. First one, that is the grid type strain gauge, torque type strain gauge, helical type strain gauge, and last one, that is the rosette type strain gauge. Now we are going to discuss all these four different type of wire strain gauge in detail. So starting with the grid type strain gauge. Okay, as we can see over here, this is one simple grid. Okay, let's see this. The wire must be able to measure the strain along one axis. Okay, the wire must be able to measure strain along one axis, only one axis, that is this axis. Okay, the meaning of axis of strain gauge is its longitudinal axis. Okay, that is the longitudinal axis in which we are going to apply our force. The longitudinal axis is parallel to the wire element. Okay, it is going to be parallel to the wire element, and we are going to give some amount of force from this direction. Now, when a member is located along the transfer axis of the gauge is subjected to the strain. The strain that is being measured along the longitudinal axis is also affected, and this process or this procedure produce some error in the response of the gauge. Okay, a certain amount of strain is present along the transfer axis, and the transfer axis, that is the sensitivity of the transfer axis, has considered while measuring the output of the final stage. Okay, and we cannot completely eliminate the transfer axis sensitivity because the output result is going to depend on that. Okay, hence in order to obtain accurate result we must compensate for the gauge error. Okay, now let's see the second one, that is the rosette type strain gauge. As we can see in the figure, let's see the figure first. This is the figure of rosette type strain gauge. Okay, over here the different types of gauge or gauge wire are located at a 45-degree angle. Okay, at a 45-degree angle. Over here we have gauge number or the wire number 1, and here's the end of the wire number 1. Over here that is the wire number 2, and here is the wire number 3. Okay, so these are the terminals of the wire, and this is the base from where we can measure our value of force. So from the figure, a rosette type strain gauge with 3 elements strain gauge. Okay, 3 element because we have 3 different wire, right? The angle between any two longitudinal axis is going to be 45-degree axis. Okay, this is the 45-degree. Then after, for a component, if the axis of strain is unknown, the strain gauge transducer can be used to determine the exact direction. Okay, because we have different 3 types of, or we can say different 3 element strain gauge, we can exactly define the direction of the force that is going to be applied, and this method required several strain gauge. The strain gauge are placed at a point on a member's surface on which we are going to measure our force. We need to place our strain gauge on that member surface, right? The angle between the gauge are known because we know it is going to be 45, and if we are going to place a multiple gauge, different type of multiple gauge on the member surface, we are also going to know the position of that gauge, right? And the magnitude of the strain in the individual gauge is measured. This magnitude is used in geometrical determination of the strain in the members. Okay, so from where we can also define from the which direction the force is applied on the surface. Okay, now moving forward, this is the Rosset type strain gauge, and we have different three terminals, and with respect to each other, with respect to 2, our terminal number 3 is at a 45 angle. Okay, so we have different type of arrangement over here in Rosset type strain gauge. Now torque and helical type strain gauge. Here in the figure A, that is going to be indicate a torque type strain gauge, and figure B, that is going to indicate a helical type strain gauge, right? And such measurement to be proved at a cross point of the shape. Okay, we need to measure the cross point of the frame. At that time we can measure the force. The attached foil strain gauge is least developed strain gauge. Okay, it employed on some PCBs design technique. The electrical as well as physical characteristics of the foil strain gauge are superior in comparison to the bonded wire strain gauge, because the angle and the position of the wire is very much of different than the bonded type of strain gauge. Okay, now let's see the next, that is the characteristics of a resistance wire strain gauge. The value of gauge factor should be high. Okay, this is the value of gauge factor, and the theory of gauge factor we already studied, right? That is the GF is equal to 1 plus twice V, that is V is equal to Poisson's ratio. Okay, a high value of gauge factor indicate that all large element or all the large change in resistance for specific strain. So whenever we are applying our value of force, we are going to get large amount of strain gauge, that is sorry, large amount of gauge factor, right? From that, the result, or we can say the sensitivity of the result, is going to be very high, because what is gauge? Our gauge is delta R by R divided by delta L by L. So if we are going to change, the length of the gauge is very small, but the resistivity change due to that small change in length is large. At that time we can call our gauge factor is very high, right? So we need our gauge factor need very high. The strain gauge should have a low resistance temperature coefficient. It is essential to minimize the error that are caused due to the vibration in or temperature and as affected accuracy of the measurement. So we need to minimize the error by controlling the physical parameters of the surrounding medium. The strain gauge should not have any hysteresis effect in its response, and we know what is hysteresis effect. We already studied the definition of hysteresis, right? So the strain should not have any hysteresis, because if it have some hysteresis, the error is going to be produced in our output result. The resistance of strain gauge should be as high as possible. This is because high resistance minimizes the effect of undesirable vibration of resistance in the measurement circuit. This is why our resistance of the strain gauge need to be very high. Then after, the strain gauge must have a linear characteristics over entire range in order to maintain consistency of calibration. Okay, whenever we are going to change our input, our output is also need to be changed, and we know what is the linear characteristics, right? So our strain gauge should have linear characteristics for the better resultment. Okay, then after, or we can say the variation that is going to change if it indicates that the variations in resistance, because the characteristics need to be linear, so the variation in the resistance should be linear function of the time. Then after, a strain gauge transducer are used for dynamic measurement. Okay, strain gauge transducer are used for the dynamic measurement. Therefore the frequency response of the strain gauge transducer should be very high. Okay, should be very high and good. The linearity should be maintained within the accuracy limit over a complete frequency of range, and we are going to measure the dynamic characteristics with the help of strain gauge. The adhesive material are generally used for bonding. It is desired that the adhesive material should be of quick drying type. Okay, it should be insensitive to moisture to have good adhesiveness. Okay, it should have some good ruggedness with respect to the moisture. It should not get damaged very easily. Okay, then after, commonly used adhesive material are different types of ethyl cellulose cement and nitrocellular cements and bakelite cements or epoxy cements. These are the different material we can use for our adhesive material. We can use this type of material as a adhesive material for our designing of strain gauges. The leads should be of such material that have a low and suitable resistivity as well as a low resistant temperature coefficient, because leads are the output of that resistance via strain gauge, and we are going to measure the level of force with respect to these leads. So the resistance should be minimum and temperature coefficients also should be minimum, because if the temperature effect are going to change the resistance, then our output is not going to be that much accurate. Then after, next theory, that is the bonded metal foil strain gauge. Now this theory is very also important, because the bonded metal foil strain gauge are formed by rolling out a thin or this foil of the resistive material. We are going to form the rolling of this resistive material and then cutting away parts of the foil by the phototacking process to create a required grid pattern. Okay, such strain gauge are called as a bonded metal strain gauge. They are an extension of the bonded metal wires gauge. Okay, they are extension of bonded metal, because it have some, it is looking like the similar than the bonded or we can say bonded wire, but it is little bit different than the bonded metal wire strain gauge. The bonded metal foil strain gauge are similar material of wire strain gauge. Okay, they are used for stress analysis applications and for many different transducers. Okay, next, that is the metals or and alloys used in the foil wire are nichrome, constant constant base, isoelastics, and nickel and platinum. These are the different materials we are going to use in our bonded metal foil strain gauge. Okay, the foil type strain gauge have characteristics that are similar to the characteristics of a resistance wire strain gauge. The gauge factor of both the strain gauge are same. Okay, the foil type strain gauge can be fabricated on a large scale. This is the advantage of foil type strain gauge. And the foil type strain gauge wire or foil type strain gauge can be acquired any shape. Okay, we can change the shape of that strain gauge. The foil can be attached on any carrier because it has some kind of foil type shape. So we can attach to any type of surface our strain gauge. Now, the advantage of foil strain gauge, these are: the foil is more thin than the wire. Okay, foil is going to be more thin than wire, hence it is more flexible. It gives a longer area for dissipation at heat generated by the current flowing in the gauge. So whenever a large amount of current is going to flow from our current gauge, at that time the resistance of that gauge is also high. So there is possibility that I square R loss, that is the heat loss, is also going to be generated. That is going to be damage our gauges. But due to the thin wire strain gauge, the heat dissipation is very good. Okay, due to the photo teaching or photo etching technique used, it is possible to produce the foil gauge of same characteristics. The foil gauge has much smaller dimension and compared to other types. Okay, because we can use this type of foil strain gauge in different applications where we cannot use our other gauges, because the foil type strain gauge has a very small size or small dimensions. Now moving forward, the next theory, that is semiconductor strain gauge. Semiconductor gauge are used in applications where high gauge factor is desired. Okay, high gauge factor is desired. Now we also know what is gauge factor: delta R by R divided by delta L by L. So whenever the change in length is very small but the change in resistance is very high, at that time we can call as a gauge factor is very good. A high gauge factor means relatively higher change in resistance that can be measured with good accuracy. Okay, the resistance of the semiconductor gauge changes as strain is applied to it. Okay, whenever we are going to apply a strain, the resistance of the semiconductor is going to be changed, and due to that change we can get our output result. The semiconductor gauge depends on their applications or depend on their actions upon the piezoresistive effect, that is the change in value of resistance due to change in resistivity. Okay, these are the different connection or different types of strain gauge, semiconductor strain gauge. These are terminals. Okay, over here we can see the side terminals are connected, and we are going to use a gold wire inside of our semiconductor strain gauge. This is also our different two terminal, and this is called as a base, and semiconductor material is over here. So whenever the force is applied, at that time the resistance of this semiconductor material is going to be changed, and which we can observe from our two terminals. Now here are some important, or we can say important questions in this video lecture, which are used in your, which are very useful for your examination. So please note this down, and if you have any kind of questions regarding this session, and you can ask me in comment section. Thank you.